A very good morning to all of our students. I am Dr. Umar Nazir, working as demonstrator in the Department of Community Medicine, Government Medical College, Srinagar. Today, I will be taking a session on concept of disease causation. This is one of the important topics to know about the spectrum of health and the causes that lead to the disease. Although health is one of the most important of all goods relating to our body, it's nevertheless the one that we consider and enjoy the least. When we have the best health, we even do not think of it. Learning objectives for this session would be: first of all, we will know about the introduction and the definition of health. After that, we'll come across the concepts of disease causation, in which we'll come across theories of disease, natural history of disease, and what is the iceberg phenomenon of the disease. Secondly, we'll go through the screening of disease. We will go about aims and objectives of a screening, uses of screening, and types of screening. Now about the introduction part of health. Health is now considered to be one of the most precious goods in our life, and it's also considered as an integral component of the overall socio-economical development of any country. Good health is central to living a long, prosperous, and active life for any member of the society. Therefore, health should be protected and enhanced as much as we can. The maintenance and promotion of health are achieved through different combination of physical, mental, and social factors, together sometimes referred as the health triangle. Now about the definition of health. According to WHO, health is a state of complete physical, mental, social, and spiritual well-being, and not merely an absence of diseases or infirmity. Diseases have got varying shades and spectrum, from subclinical states to the severe illness. The onset of disease may be acute, as in case of food poisonings, or insidious, as in mental illness, rheumatoid arthritis. Sometimes the diseased person may look apparently healthy, but may be spreading infection to others, as in carrier states of typhoid fever, or nowadays in COVID-19. The same pathogen sometimes cause more than one disease. Example, streptococcal infection. It can have presentations like pharyngitis, pneumonitis, endocarditis, or sometimes rheumatic fever also. The same disease sometimes caused by more than one organism. Example, we have diarrheal disease. It can be of bacterial origin or virus like rotavirus or protozoal infection. The course of a disease may be shortened or prolonged. It's challenging to demarcate between a normal and the abnormal state in some diseases like hypertension, diabetes, mental illness. The endpoint or the outcome of a disease is variable. It can be either recovery or disability or death. Now about the various theories of disease causation. There have been various theories since ancient times to the modern era. Among these theories are the old theories. Among them, the first one is the supernatural theory. In this theory, it was thought that a punishment is given from the God for a sinner for his behavior. Example, curse of a god or an evil eye. Second one from the old theories is the Ayurveda. Ayurveda is the traditional Hindu system of medicine, the last of the four Vedas, which is based on the idea of balance in bodily systems and use diet, herbal treatment, and yoga as the mode of treatments. It was thought that the disease is due to imbalance of the tridosha. That means three energies. Number one is the vata, air. Number second is the pitta, that's bile. And the third one is the kapha, that's mucus. Third one from the old theories is the miasma theory. The word miasma means pollution. Miasma was considered to be a poisonous vapor or mist filled with particles from decomposed matter miasmata that caused illnesses. The miasma theory is an obsolete medical theory nowadays that held that diseases such as cholera, chlamydia, or the Black Death, also called Kala Azar. They were caused by a miasma, a noxious form of bad air, also known as night air. The theory held that epidemics were caused by miasma, that's from that bad air emanating from rotting organic matter. Now, the last from the old theories is from the Chinese medicine. They believed that the disease is caused by an imbalance of male principle yang and the female principle yin. Now, we will next slide will go about the germ theory of the disease. The discoveries in microbiology in the 18th century became a turning point in the etiological concept of disease. Louis Pasteur in 1860 demonstrated the presence of bacteria in the air, and the Robert Koch in 1887 showed that bacteria caused anthrax. These discoveries of Pasteur and Koch confirmed the germ theory of disease. Health problems were believed to be the product of these living organisms which entered the body through food, water, air, or the bites of the insects or animals. In this model, it was believed that each disease has a single and a specific cause, monocausal approach for developing disease. However, late in the 20th century, it was recognized that a disease is rarely caused by a single agent alone, but depends upon many contributory factors. These are the factors relating to the host and environment, which are equally important to determine the occurrence of disease. That demands a broader concept of disease causation that synthesizes the fundamental factors of agent, host, and environment, what's nowadays called epidemiological triad. The result of the germ theory was that researchers were moved from the community to the laboratory and concentrated on the identification of agents for a given disease. Here, we don't have the multifactorial causation of disease discussed. Now about the biomedical model of disease causation. The biomedical model of medicine has been around since the mid 19th century as the predominant model used by the physicians in diagnosing diseases. The biomedical model of health focuses on purely biological factors and excludes psychological, environmental, and social influences. It's considered to be the leading modern way for healthcare professionals to diagnose and treat a condition in most Western countries. Diseases as a result of malfunctioning of organs or cells. For example, diabetes mellitus is caused by malfunctioning of pancreas. Multifactorial causation of disease. After the doctrine of one-to-one relationship between cause and disease has been shown to be unjustifiable even for microbial diseases like tuberculosis, leprosy, the theory of multifactorial causation was given by Pettenkofer of Munch. This theory de-emphasizes the germ theory. Modern epidemiology has also contributed significantly to our present day understanding of the multifactorial causation of disease. Nowadays, the epidemiologists are looking beyond the germ theory of disease into the total life situation of the patient and the community in search of multiple risk factors of disease. This new theory includes all facets of the communicable disease model, and to make it more relevant and useful with regard to today's diseases, conditions, disorders, defects, injuries, and deaths. This theory has taken into account all the behavior, lifestyle factors, environmental causes, culture, physiological factors, ecological elements, and physical factors. As a result of advance in public health, It's now well recognized that many diseases are neither caused by an organism nor they could be prevented by traditional methods of isolation, immunization, or improvements in sanitation. These diseases are predisposed by many factors: social, economic, cultural, genetic, and psychological, contributing to its occurrence, especially in the case of modern disease of civilization like coronary heart disease, various types of cancers, many types of diabetes, chronic obstructive pulmonary disease, mental illnesses. Now about the epidemiological triad. The triad consists of external agent or pathogen, a susceptible host, and the environment that brings the host and agent together. According to this theory, exposure to an external agent does not necessarily lead to disease. It was believed that the disease is a result of an interaction between the agent, host, and the environment. Thus, this model explains that some persons do not suffer from the disease even though they harbor the pathogens from that disease because equilibrium is established between the causative agent and the host. Now about the external agent in the epidemiological triad. The agent may be defined as a substance, living or non-living, or a force, tangible or intangible, the excessive presence or relative lack of which is the immediate cause of a particular disease. The disease agents into broad group as follows: biological agents, nutrient agents, physical agents, chemical agents, and the mechanical agents. In biological agents, we have viruses, bacteria, fungi, protozoa, helminths, and arthropods. These agents have some host related biological features. Nutrient agents, these are proteins, fats, carbohydrates, vitamins, minerals, and water. Any excess or deficiency of these nutrient elements may result in nutritional disorders. Some of the current nutritional problems are protein energy malnutrition in children, anemia, goiter, obesity, and vitamin deficiencies like scurvy, rickets. Physical agents, excessive heat, cold, humidity, noise, atmospheric pressure, radiation, electricity, and sounds can also be a form of the agents. Chemical agents, it includes both endogenous and exogenous agents inside and outside the body. They are mainly of two types. Endogenous, these chemicals are produced in the body as a result of derangement of functions. Example: urea in uremia, serum bilirubin, jaundice, glucose in diabetes, ketones, ketosis, uric acid in gout, calcium carbonates, calcium oxalates, which form kidney stones. Exogenous, these agents arise outside of a human body or host, like allergens, metals, fumes, dust, gases, insecticides. They may be acquired by inhalation, ingestion, or inoculation. And the last one in the agents is the mechanical agents. These are chronic friction or other mechanical forces like injury, sprain, accidents resulting in crushing, tearing, sprains, dislocations, and fractures, and sometimes even deaths, like we do have in road traffic accidents. Now, about the second factor that's important in the epidemiological triad is the susceptible host. In the disease process, the human host factor is very complex. In epidemiological terms, the human host is referred to as soil and the disease as seed. The host contribution to disease is first thought by his inherited or genetic characteristics, all of which must be considered while considering the natural history of the disease. The association of any particular disease with a specific set of host factors frequently provide an insight into the cause of any disease. These are age, sex, race, genetics, nutrition, occupation, immunity status, customs, habits, human behavior, and psychological factors. In some situations, Like in tuberculosis, host factor play a significant role in determining the outcome of an individual exposure to infection. The third important factor in the epidemiological triad is the environment. The environment is the surroundings or conditions within a host or external to it in the community that can cause or allow the disease transmission. The relationship between environment and disease is very complex as millions of people are suffered by the disease originating in the environment. They are classified into physical, biological, and psychosocial environment. Physical environment, it's applied to non-living things and physical factors, example air, water, soil, housing, climate, geography, heat, light, noise, debris, radiation, sanitation. Biological environment, it's a universe of living things which surrounds the man, including man himself, viruses, and other microbial agents, insects, rodents, animals, and plants. Third one is the psychological environment. These include cultural values, customs, habits, beliefs, attitudes, morals, religion, education, lifestyles, community life, health services, and social and political organizations. A harmonious adjustment to the environment enables man to enjoy health and happiness, whereas maladjustment may not only cause illness but may also deprive a man of taking adequate action against the disease. Now about the web of causation. McMahon and Pug gave this model of disease causation in their book Epidemiological Principles and Methods. This model is basically for the study of non communicable diseases, where the disease agent is often not recognized, but the disease is an outcome of an interaction of multiple factors like biophysical, social, and psychological factors. The web of causation considers all the predisposing risk factors of any type and their complex interrelationship with each other. For example, the multiple predisposing factors in the web of causation of coronary heart disease are excess of smoking, high blood pressure, high cholesterol, obesity, lack of exercise, type A personalities. These are considered as risk factors in the web of causation of disease. This model shows a variety of possible interventions that could be taken which might reduce the occurrence of coronary heart disease. The web of causation does not imply that the disease cannot be controlled until all the multiple causes or chains of causation, or at least a number of them, are appropriately controlled or removed. Sometimes removal or elimination of only one crucial link may be sufficient to control the disease, provided that link is sufficiently important in the pathogenesis process. In a multifactorial event, therefore, individual factors do not have equal weightage. The relative importance of these factors may be expressed concerning relative risk. Now about the natural history of the disease. While discussing at the beginning of the session about the concept of disease, it is evident that the disease is nothing but a process. The term natural history of the disease is applied to the course of the disease process in man. In the absence of any intervention, either preventive or the treatment part, all diseases follow a natural course of events, which refers to the natural history of disease. The natural history of disease occurs in two phases: pre-pathogenesis phases and the pathogenesis phase. Pre-pathogenesis phase refers to the period before the onset of disease. During this phase, interaction is taking place amongst the three components of epidemiological triad as agent, host, and environment, each representing the angle of a triangle respectively. As long as there is equilibrium among these three interacting factors, so long the person will be healthy. Once the equilibrium is disturbed, disease process starts. In other words, potentially we all are in the pre-pathogenesis phase of many diseases, both communicable and non-communicable disease. Just like when the seeds are plowed into the soil, crops are grown under favorable conditions. So also when the causative agent invades the host, disease occurs under favorable environment. Depending upon the interaction, there may be development of either one case or epidemic. Now about the pathogenesis phase. The period of pathogenesis phase starts when the causative disease agent enters the human body successfully. Having entered the body, irrespective of the route, goes to the site selection, lodges there, gets adopted, multiplies, reach an optimal number, disturbs the structure and function of that organ, produces change in the blood and tissue fluid, and results in the development of signs and symptoms of a disease. The period between the successful entrance of the organism and the onset of first symptom is called the incubation period. After the onset of clinical features, the final outcome of any disease may be total recovery, chronic disease form, disability, or death of the individual. Now about the iceberg phenomenon of the disease. The iceberg phenomenon describes a situation in which a large percentage of problem is subclinical or unreported or sometimes hidden from the view. When a piece of ice is allowed to float on water, only a small portion is visible and a significant portion is submerged in the water. The floating tip, which we see in this picture, are the cases which are seen by the physician, or these are the clinical cases or deaths which take place in the community. Large submerged portion which you see in this picture are the hidden masses of disease, or they are pre-symptomatic, or they are underdiagnosed, or they are carriers, which are all responsible for the constant prevalence of the disease in the community. The line of demarcation or the water surface which you see in the picture is between the apparent and the inapparent infections. Water surrounding the iceberg is the healthy population. In some diseases like hypertension, diabetes, anemia, malnutrition, mental illness, the unknown morbidity, that's the submerged portion of the iceberg, far exceeds the known morbidity. Epidemiologist is concerned with the hidden portion of an iceberg, while our clinicians are always concerned with the tip of iceberg. Now about the screening for disease. Screening is done for a hidden portion of iceberg, whereas diagnosis is made from the tip of the iceberg. What is a screening test? We must know that. A screening test is done to detect the potential health disorders or diseases in people who do not have any symptom of disease. The goal is early detection and lifestyle change or surveillance to reduce the risk of disease or detect it early enough to treat it most effectively. Search for unrecognized disease or defects by means of a rapidly applied test, examinations, or other procedures. Like what we do in COVID 19, we do rapid antigen tests to detect the virus in the apparently healthy population or asymptomatic carriers. Aims and objectives of a screening test. The aim of the first step is to look for signs of the disease in question. The results of a screening test are considered to be positive if signs of the disease are found, and negative if no signs of the disease are found. The second step involves doing further tests to enable a more accurate diagnosis. It helps us to sort out apparently healthy persons likely to have the disease. And secondly, brings apparently abnormal persons under medical supervision and treatment who do not have any symptoms or signs and look apparently healthy. Now about the uses of a screening test. Screening tests are used for early case detection. People are screened for their own benefit. For example, diseases can be detected early and treated early so that complications are prevented. This is called prescriptive screening. For example, screening of a newborn, of a pregnant woman, for bacteria, detection of CSCX, diabetes, hypertension, and many others. Screening is also used for control of the disease. People are screened for the benefit of others. That's by early diagnosis and early treatment to reduce further spread in the community. This is called prospective screening. Screening of the immigrants for HIV, pulmonary tuberculosis, syphilis, screening of blood donors, or nowadays we screen healthy people for COVID 19 by doing rat tests. This helps us in reducing morbidity and mortality of the disease. Screening is also used for research purpose. Screening helps to know more about the natural history of the disease. For example, initial screening helps us to know about the prevalence of disease and the subsequent screening, the incidence of it, also gives information about the risk factors and the risk groups that lead to the disease. And lastly, for educational purpose, screening procedure creates awareness among the people about the disease, thus educating the public about the disease. Types of screening tests. There are five types of screening procedures: mass screening, high risk screening, multipurpose screening, multiphasic screening, and the opportunistic screening. Mass screening. This is the screening of the entire population of an area for a disease. For example, night blood smear examination for mycophilaria of every individual in hyperendemic area of filariasis. However, this is not an usual preventive measure unless it's backed up by the treatment and the follow-up. Second one is the high risk screening. This is the screening of only those group of population who are at high risk of the disease and not of the entire population. This is also called selective screening or the targeted screening. For example, screening of women of low socioeconomic class for cervical carcinoma or obese people for hypertension or diabetes. Number third is the multipurpose screening. This is a screening of a group of population by application of two or more tests at one time to detect more number of diseases. For example, screening of pregnant women with the blood for HB, VDRL, ELISA for HIV, surface antigen for HBV, for blood grouping and RH typing. Number four is the multiphasic screening. This is the screening of population by applying different tests in different phases for the diagnosis of one disease. For example, the whole population of an area is screened for testing urine for sugar. Those who are positive for glyceruria are subjected for fasting blood sugar level. Those who have a fasting blood sugar level of greater than 120 milligrams per deciliter are subjected for oral glucose tolerance test to find out the true diabetics. And the last one is the opportunistic screening. This is the screening of a patient who consults the doctor for some other purpose. This is also called case finding screening. With this, we conclude today's session on disease causation. Thank you.